by drawing. Okay, تمام. I will send the answers, no problem. Okay, so what they ask: resultant, force, and vector quantities. What's the difference between scalar and vector quantities? Yes, send me the answers. What the difference, the main difference between scalar quantities and vector quantities? Vector quantities, they have what? That scalar quantities, they don't have it. Yes, shukran ya Salma, shukran ya Abdurrahman, they have direction. Okay, and the direction, it's very important because whenever we change direction, we change the value here. Okay, the magnitude will change, the value change. So first question here, let's try to answer together. State the factor which completely describe a vector quantity. They have what direction, or it has a direction. Okay, tamam. That's one mark. Next, what they ask. Next, what do they ask? I will try to open an something that can show me. Hold on. Yes. I'll try to open something that can show me how I can draw what a vector diagram using what a ruler. Okay. This is the device. Okay. I have a protractor. I have a compass. Okay, and I can do whatever I want here. Okay. So, for example, first question here, what they ask. Let's see the question. An airplane is flying towards the east. It's flying towards the east in still air with a speed of how much? 92 meters per second. That's in still air. That's the speed of the airplane relative to where? To the wind, relative to the air. Okay. If there is a wind now, a wind starts to blow 24 meters per second towards the what? The north. Now, as the airplane is moving to the east, and there is blowing of the wind to the north, that means this airplane, it will shift a little bit where? To the north, like this. نعيد مرة تانية. The airplane is supposed to go to the east. Why the east is the right? Because all of the people on the earth, they agree that this is the north, this is the south, this is the east, this is the west. News, okay? News. تمام? As the airplane is moving to the east with this speed, which is 92, there is air blowing it upwards. So the final position of the airplane, it will not be here. It will be 24 kilometers per hour, or sorry, 24 meters per second in this position. So that means my answer, okay, it will not be to the right. It will not be upwards. It will be from where I started, or the airplane started, okay, to where I finish in this position. And I will draw it was as a straight line like this. Okay, تمام. So كيف بدي أحل هيك سؤال? How can I solve this question? First of all, I have to look to what? To the areas that I have it, okay, to draw it. Because I'm talking about two vectors, one to the right and one upwards. So eventually, I'm talking that I'll start from the left corner down here and go to the right corner up. But before I started, I have to put my own what? My own scale. Okay. Now in this device, I have a small ruler like this one. Okay. It has a small scale. It's not real one like the one that you have it. Okay. And I can use a compass. Okay. So I have also what? Sorry, a protractor or a compass. Okay. Now, what will be my scale? It's very important here to know what the scale that you are going to use. And let's say that I'm going to use that they say that each 1 centimeter, they give it to us, each 1 centimeter is equal to 10 meters per second. That means the 92 meters per second, it will be equal 9.2 centimeter, okay? And the 24 meters per second, it will be 2.4 what? Centimeter. Okay, they give us the scale. Sometimes they don't, so we have to use our own scale. Okay, now, tamam. I don't know why you put the negative. It's north, upwards. Okay, so what I will do, I bring my ruler, okay, and draw a horizontal line that represents the 9.2 centimeter to the east. Okay, so this is 0. Okay, and I draw it from 0 and keep drawing to until how much? 9.2. Okay, that's my drawing. Then what? I bring my ruler and put it on the edge. I bring my protractor. It's supposed to be 90 degrees like this. So I have to draw something that reach this line here. Okay, 90 degrees perpendicular by the ruler. So I put my ruler at the end where I started drawing. That's the first line. The second line, I'll draw it like this. And I go upwards vertically to how much? Vertically to 90 degrees. Then I'll use my ruler and draw 2.4 centimeter like this. Okay, 2.4 centimeter like this. Okay, so then whenever I finish this drawing, I have to what? To label that this is 92 meters per second, and this is what? 24 meters per second. My answer, it will be what? My answer, it will be from where I started drawing, okay, where I'm going to start my first force to where I reach the last force like this. I use my pencil, okay, and I draw this line and I measure it. How long it will be? The length of this line that I draw it is the resultant.
Pythagoras.
I didn't hear what?
Pythagoras.
You can do that in Pythagoras. Yes, you can. But my last answer, أنا مش عارف ليش عم بنزل تحت قاعد. الدروينج ليش عم تنزل تحت. But my last answer, if I draw it here, okay. أيوه هيك. My last answer, it will be 95. If I measure it, it will be 9.5. هاي البروتراك هاي الرولر طلع قد طوله بالضبط 9.5. So according to my scale, okay, the scale said that it's supposed to be
95 meters per second.
Exactly, 95 meters per second. So here my answer, it will be 95 meters per second. Now this is the first part. Second part, hold on.
Sir.
Yes. Hold on.
When I use
Second part, I have to use the protractor to measure the angle, okay, that it's supposed to be. And as you can see, the direction of the resultant to the eastern direction, as they ask, it's how many degrees? It's 10, 11, 12, 13, 14, 15, exactly. So the direction, it will be 15 degrees to the horizontal. Yes, hold on. خليني أشوف الشغلة. Okay, question number 2. طبعا it's a part of a question, along the question. I put on this, only this part of it. Okay, what they say. The figure shows what the top view of what a tourism vehicle in a game park, تمام, and 2 elephants pushing against the vehicle. عاصفين على ايش elephants? I don't know. The 2 forces indicate are at right angle, 90 degrees to each other. Okay, one act to the right, and one acts upwards on this point of view. Okay, so we have 4 kilonewton, 4,000 Newton, and 6,000 Newton, 6 kilonewton. Okay. In the space below, draw a scale vector diagram. Okay. The magnitude of the resultant force of these 2 elephants. Okay. Label the 2 forces and the resultant and clearly state your scale. Okay. Now, actually, I'll make a very easy scale that each 1 kilonewton is equal to how much? 1 centimeter. Can I do that? Each 1 kilonewton is equal to what? 1 centimeter. That's my scale. Okay. So how can I do that? I bring my ruler and my protractor. Okay. So this is the ruler. I'll draw what a line to the right, as I told you now. How far it's supposed to be, how long it's supposed to be, 4 centimeters. Okay, so 0, 1, 2, 3, 4 until the end of 4 centimeter. I stop. I bring my ruler. I need to to make sure that my angle is 90 degrees. So I bring my protractor and put it on the edge. I draw a mark, a line here. Okay. Now my ruler supposed to be starting from where I finish. So this is my first force, and I will rotate it. Okay, spin it to find the angle of 90 degrees. Okay, like this. Then I will draw my other force. My other force supposed to be how many centimeter? 6 kilonewton. So I will draw 6 what? I don't know why it's not a straight line. Let me check. Okay. I will draw by my ruler what, a 6 centimeter from where I start to where I finish. Okay. This is my second force. So this is the 6 kilo Newton. And the other one here, it's the 4 kilo Newton. My answer is the resultant. It's from where I started to where I finish. Okay. I'll draw with my pencil, with my pen. Okay. And it will be a straight line like this. And as I told you, as I measure it here, it's obvious that 7.2. So this is 7.2 kilowatt Newton, or 7.2 centimeter. This is my my scale. Okay. Now maybe they will ask about this angle. Okay. For sure they will ask about the direction. Angle of the resultant from the right. So I bring my protractor. Sorry, my protractor, yes. And I'll measure the angle. It's 0, 10, 20, 30, 40, 50. It's approximately 55 or 56. It's, yes, approximately 56 or 57. And that's how we can get the answer. If you please, ya Shabab, I want from you to try to do it by yourself. Okay? I want to redraw this and send it to me right now. Okay? Yes, if you. Here also in this question, we need to find out how much is the weight of the box. Now we know that the weight of the box acts on the point B, or P, sorry, on the point P downwards, and it's equal and cancelled by these two forces upwards. So that means the 1220 Newton force and the 950 Newton, they act with different angle, but eventually their resultants acts upwards by a force equal and cancel the weight downwards. On a scale diagram, not calculation, okay, on the forces acting on the P, find the weight of the box. We need to find the weight of the box. As I told you here, we have to put a scale and we have to know how to draw it, okay? Now, I have a whole page empty. My advice to you to start to draw from here, okay? Start drawing from where? From the bottom, like this here, and somewhere here, okay? Why? Because you need the whole area here. What is the scale that I will do? If I said 1 centimeter, 1 Newton, I need a whole land to draw this drawing. I can't do that. My whole disk cannot do that, not only the page here, the paper. So what I will do? I will make the scale smaller. Why? What that means? Each 1 centimeter, it's equal approximately 100. Okay? Each 1 centimeter is equal 100 what? A Newton. That means this force, okay, the 1220 Newton, it will be how much? 12.2 centimeter. And the other force, which is 950 Newton, okay, it will be to equal 9.5 what? Centimeter. Okay, that's how I'm going to draw it. Okay, تمام. Okay, خلينا نشوف كيف الرسم حيكون. Now, as I told you, I'll bring what? My protractor and my compass. Okay, يا الله. I will use my tools. Okay, ruler, protractor. Look here. This is my ruler, and this is what my protractor or my compass. Later on, I'm going to show you how to use the compass. Now, I will draw two forces, okay, but I have to make sure that my resultant is vertically upwards. So from the vertical line, as they give us, from the vertical line, okay, I'll draw what? I'll draw the force with 12 centimeter, 12.2, okay, 30 degrees to the right. So this is, okay, 10, 0, 10, this is the vertical, 10, 20, 30, okay, from this point, I'll use my ruler and put it like this, and make sure that I'll draw a line with 12.2 centimeter, okay. This is my line, start from 0, continue to 12.2, stop. Then at this point, this is my angle. How much is the angle? 30 from the vertical line, okay. From this point, I'll draw another force. How much? 70 degrees to where? To the left of the direction how I was drawing it. كيف بدي ارسم هذا الحكي؟ We know in triangles, if I have this line, okay, and I have intersection somewhere here, and there is a vertical line like this, okay, and they tell us that this angle is 30 degrees and this angle is 70 degrees in a straight line. So how much is this angle? The whole this angle is 70, 30 plus 40. So how much left? The whole straight line angle is 180 minus 70. So here it's 110 degrees. So I will use my protractor to draw what? Another force with an angle of how much? 110, okay? 110 degrees from where? From this direction. So I put my protractor here, put the protractor at 0, and measure how much is what? 110. This is 110. So 0, 1, 2, 3, 4, 5, 6, 90, 100, 110. Then I will use my what? My protractor, my ruler to draw what? The other line that's supposed to be how many centimeters? Yes, how many centimeters supposed to be? 9.5. So I put my ruler here and draw 9.5 centimeter. This is 1, 2, 3, 4, 5, 6, 7, 8, 9.5. It will be a straight line like this. Where's my answer? Again, this is the 1220 Newton. And this is the 950 watt Newton. Where's my answer? My answer is supposed to be from where I started, from the beginning here, until where what? I finished drawing, until here. I'll draw it with a green line. As you can see, it
Why
is
you wrote 950?
17.2. I didn't hear you. 17.8 centimeter. So it will be 1780 Newton. Again, ya shabab,